Welcome to chemistry classes. In this video we are going to discuss about electrochemistry. Electrochemistry. Electrochemistry means branch of chemistry which deals electricity and chemical change. Electrochemical cells. Electrochemical cells or cells. Cells mean device which convert chemical energy to electrical energy. Example for cells. Cells or batteries that we used in torch or watch, TV remotes, etc. These are example for cells. It convert chemical energy to electrical energy. Next one, electrolytic cells. Electrolytic cells are the cells which convert electrical energy to chemical energy. Okay, so we have two cells, electrochemical cells and electrolytic cells. The basic difference between electrochemical cells and electrolytic cells mean electrochemical cells, it convert chemical energy to electrical energy, and it work without external supply of energy. So electrochemical cells mean cells it convert chemical energy to electrical energy and it produce energy by itself. It work without external energy, that is electrochemical cells. Electrolytic cells mean cells it convert electrical energy to chemical energy. It work with external energy. It need external energy. Okay. Example for electrolytic cells. Batteries which used in mobile phone. Batteries which used in mobile phone. It is example for electrolytic cells. Electrochemical cells and electrolytic cells, the basic reactions which taking place in electrochemical cells and electrolytic cells are redox reaction. Redox reaction means chemical reaction in which both oxidation and reduction takes place. Okay, so in electrochemical cells and electrolytic cells, redox reaction takes place. One, a cell consists of two half cells. See this diagram. It shows a cell. It consists of two half cells. Two half cells are connected with a salt bridge. Two half cells which connected with salt bridge. Okay, and a cell consists of two half cell. One half cell is oxidation. In one cell oxidation takes place. It is called oxidation electrode. Oxidation electrode. Okay, and another one reduction takes place and it is reduction electrode. Reduction electrode. For example, see here E0. E0 means standard electrode potential. Standard electrode potential. Okay, here Fe to Fe2 plus, Fe to Fe2 plus, Fe change to Fe2 plus mean it is oxidation. The potential difference here oxidation electrode potential. Here positive 0.44 volt. It is oxidation electrode potential. The positive value, the potential difference positive value always represent oxidation. See next one E0 Fe2 plus to Fe. Fe2 plus change to Fe. Fe2 plus receive electron and change to Fe. It is reduction. The potential difference of this one reduction electrode potential. Reduction electrode potential and its value always negative. Minus 0.44 volt. Negative value always represent reduction. Reduction electrode potential. Next one, standard hydrogen electrode. Standard hydrogen electrode. We already discussed here representation of a cell. A cell consists of two half cell. Okay, half cell. Half cell mean one metal it inserted. A metal which inserted into its own solution. For example, zinc electrode inserted into zinc sulfate solution, or copper electrode inserted into aqueous copper sulfate solution. So there will be a potential difference between this metal and aqueous solution. For example, copper electrode and aqueous copper sulfate solution. There will be a potential difference. This potential difference is electrode potential. Electrode potential. Okay, if we measure this potential difference at standard condition mean 1 atmospheric pressure, 25 degrees Celsius, and aqueous solution, its concentration 1 molar concentration, then it is called standard electrode potential. Okay, so this standard electrode potential we can measure with help of standard hydrogen electrode. Here this diagram showing standard hydrogen electrode. Standard hydrogen electrode mean a container which contain 1 molar solution with H plus ion, solution which contain 1 molar H plus ion. For example, 1 molar HCl or 1 molar H2SO4. Okay, and there is a glass tube as shown in this figure. There will be a glass rod with a platinum foil, and this platinum foil hanging on a platinum wire. Okay, also hydrogen gas is continuously passing into this solution. So this apparatus arrangement called standard hydrogen electrode. 1 molar aqueous solution which contain H plus ion, and there will be a platinum foil which hanging on platinum wire, and hydrogen gas is continuously passing through this glass tube. This is the apparatus arrangement for standard hydrogen electrode. The electrode potential of standard hydrogen electrode, it is 0 volt, and we can measure standard hydrogen, we can measure electrode potential of different half cells compared to standard hydrogen electrode. Example, you want to measure electrode potential of copper electrode. So we have to connect copper electrode with the standard hydrogen electrode, and we will get corresponding reading. And if you want to measure the electrode potential for zinc electrode, we have to connect zinc electrode with standard hydrogen electrode, and we will get the electrode potential reading. Okay, after connecting a cell with standard hydrogen electrode, if the value is less than 0, if the potential is less than 0, it has a negative potential. If the potential is more than 0, it will be a positive value. It is positive potential. Next one we have to discuss here, writing an electrochemical cell. Writing an electrochemical cell using given electrode. For example, we have given here electrode potential, standard electrode potential for copper Cu2 plus to Cu, positive 0.34 volt. Standard electrode potential Zn2 plus to Zn equal to minus 0.76. Okay, so you are given this value, and you have to write here electrochemical cell using this value. So here copper, electrode potential for copper Cu2 plus to Cu given positive 0.34. Here positive value, it represent oxidation takes place. Positive value showing oxidation takes place at copper. Writing an electrochemical cell using given electrode. Okay, you are given an electrode potential value. Using this electrode potential value, we can write here we can write here electrochemical cell. Okay, for example, look here, electrode potential for Cu2 plus to Cu, it is positive 0.34 volt. Electrode potential for Zn2 plus to Zn, it is minus 0.76. So electrode potential for copper positive 0.34. Positive value showing that reduction takes place in copper electrode. Positive value shows reduction takes place. Reduction means Cu2 plus receive 2 electron change to Cu. And in zinc electrode, electrode potential for zinc, it is minus 0.76. Negative value showing that in zinc electrode oxidation takes place. Zinc lose electron, zinc lose 2 electron and change to Zn. Okay, so Cu2 plus 2, Cu2 plus 2 electron, Cu, Zn lose 2 electron, Zn gives Zn2 plus 2 electron. This is the reaction taking place. Now how can we represent here electrochemical cell? See here right hand side I'm showing here how to write electrochemical cell. So when you are writing electrochemical cell, you have to write always right hand side you have to show cathode and left hand side you have to show anode. Cathode mean electrode in which reduction takes place. Here copper Cu2 plus to Cu, positive value, reduction taking place, so it is cathode, so it will be right hand side. And left hand side anode. Here zinc lose electron and change to Zn2 plus, so oxidation takes place at zinc electrode, so it is anode, and left hand side it will be zinc bar Zn2 plus, and here between two electrode, between Zn2 plus, Cu2 plus to Cu, there is double bar. This double bar showing salt bridge. Okay, and this is the representation for complete cell using zinc electrode and copper electrode. Okay, here also right hand side copper, it is cathode, left hand side zinc electrode, it is anode. And here zinc electrode inserted in aqueous zinc sulfate solution and copper electrode inserted in aqueous copper sulfate solution. Okay, and here we can measure standard electrode potential E0 cell. E0 cell being E0 represent standard electrode potential. Standard electrode potential of a cell equal to E0 cathode minus E0 anode. Electrode potential value for cathode minus anode. Okay, here cathode mean copper electrode value, it is given in the question, or it is given here 0.34 minus 0.76. Here 2 minus coming because the value of electrode potential zinc already minus 0.76. So the electrode potential of this cell is 1.1 volt. Okay. Next one, Nernst equation. The scientist Nernst gave a relationship between electrode potential and concentration of electrolyte. See here the equation Mn plus n electron giving M. This M represent metal and n represent integer. For example, Cu2 plus 2 electron giving Cu. M it just represent metal, any metal, and n it will be integer, depends on the metal. For example, Na plus 1 electron giving Na for sodium, Na plus. If you consider copper, Cu2 plus, so N will be 2. Cu2 plus 2 electron giving Cu. Okay, so here electrode potential em n plus bar m equal to standard electrode potential, standard E and E0. E mean electrode potential, E0 means standard electrode potential. Standard electrode potential we can measure with help of standard hydrogen electrode. Okay, so this is the relation, this is the equation for Nernst equation. E m n plus bar m equal to E0 m n plus bar m minus RT by NF ln concentration of m plus concentration of m divided by concentration of m n plus in aqueous solution. Here R, it is universal gas constant 8.314. T, temperature at standard condition temperature it will be 298 Kelvin. F, Faraday constant 96500 Coulomb. Okay, when you substitute all this value you will get the final equation. E m n plus bar m equal to E0 m n plus bar m minus 0.059 by n log 1 by concentration of m n plus in aqueous state. This is Nernst equation. Next one, some sample problems related to this topic. Here first question, calculate standard electrode potential. Calculate standard electrode potential of nickel 2 plus to nickel electrode when the cell potential for this cell is 0.59 volt. The electrochemical cell equation is given nickel to nickel 2 plus double bar Cu2 plus to Cu. This is the cell and cell potential for this cell is 0.59 volt. Okay, also given here standard electrode potential for copper electrode is 0.34 volt. It is given. Okay, so here electrochemical equation is given. We discussed already. Right hand side it will be cathode, left hand side it will be anode. Okay, we know standard cell equation or E0 cell equal to E cathode minus E anode. Okay, your cathode it is copper. So electrode potential, standard electrode potential for copper electrode minus standard electrode potential for a nickel electrode. Okay, we have to calculate here electrode potential for nickel electrode. So we can rearrange the equation like this. Okay, electrode potential for nickel electrode equal to electrode potential of copper electrode minus electrode potential for cell. So the final answer, substitute the values here and final answer will be 0.25 minus 0.25 volt. This is the answer. Next question, a cell in which the following reaction taking place, Mg plus 2Ag plus giving Mg2 plus 2Ag. This is the equation. Okay, calculate E cell for this chemical reaction. Here it is given standard electrode potential for this chemical reaction. It is 3.17 volt. Okay. So according to Nernst equation, we know E cell equal to E0 cell minus 0.059 divided by n log concentration of Mg2 plus divided by concentration of Ag2 plus. In chemical equation, product side, concentration of product divided by concentration of reactant. Okay, so concentration of product side it is Mg2 plus, reactant side it is Ag plus, 2Ag plus, so Ag plus whole square. Okay, the equation coming like this. Okay, so we know E0 cell for this chemical reaction 3.17, it is given already. So substitute remaining values over here. So final answer will be 2.96 volt. 2.96 volt. Next question. A zinc rod is dipped in 0.1 molar solution of aqueous zinc sulfate solution. The salt is 95% dissociated. 95. A zinc rod is dipped in 0.1 molar solution of aqueous zinc sulfate. The salt is 95% dissociated at 298 Kelvin. Calculate the electrode potential. Here given standard electrode potential for zinc electrode is minus 0.76 volt. Here zinc electrode dipped in aqueous zinc sulfate, only 95% is dissociated. We have to calculate electrode potential for this cell, this half cell. Okay, so we know according to Nernst's equation, electrode potential E Zn2 plus to Zn equal to E0 Zn2 plus bar Zn minus 0.059 divided by N log concentration of zinc divided by concentration of zinc Zn2 plus. Okay, here concentration of zinc, it is solid state, so you can take its concentration 1. Okay, concentration of Zn2 plus we cannot take 0.1 because not 100% dissociated, only 95% dissociated. So the concentration of Zn2 plus 0.1 times 95 divided by 100. Okay, so you will get 0.095 molar. Now you have to substitute all these values here in Nernst's equation. Finally you will get minus 0.79 volt. This is the answer. Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.